In this video, we hope to make meaning of an exponential function. We're asked if it's growth or decay. We're asked a lot of questions to just make sure that we understand the formula and the parts of the formula. So with exponential, we are working with an MPAT formula. So I'm just going to write that up here so that I can really match up the pieces that I'm given to the letters in the MPAT model. So this formula is telling us the world population in billions after the year 1900. That's a time period when population was growing, and I probably shouldn't even tell you that because that's one of the questions. But this would not be true anymore today, but it was true for the 1900s and shortly thereafter. So what was the world population in 1900? Well, 1900 is the start, and the starting value in MPAT is P, so I see that this is 1.6 billion. Was it growing or decaying? And so we already talked about that it was growing, but how do I know from the formula if I didn't know any history about that time? In the formula, I know this because our A value is greater than 1. So what does the 1.014 mean? Well, all exponential problems have a constant percent in them. So the first thing I'm going to do is I'm going to multiply this by 100 to get it to be a percent. So 101.4%. So this is telling us with this problem within years up here. And so this percentage each year the population was 101.4% of the previous year. Now, I think wording this is a little bit harder than when it's decay. When it's decay, you just say it's the percent remaining. But here, because there's been growth, it is a percentage over 100. That's the growth. And it's much easier if we actually describe it by how much it grew rather than what percentage of the previous year. So this next question is the more natural way to say this, and that is by what percent was the world population growing? And I'm crossing out the decay because we know it's growing. So when I think this through, I just want to see what difference is there between the percent I just found and 100%. So I can take 101.4, subtract out 100, and that would give me 1.4%. So it was growing by 1.4%, and that's normally how we would describe things rather than using the 101.4%. This also can be solved with algebra. Algebra is a little bit harder way, but it does work, and sometimes it just helps us to see things when we know they work. So we know that the A in a growth equation is 1 plus R. So my A value here was 1.014, and that's equal to 1 plus R. So to solve to figure out R, I subtract 1 from both sides. So 0.014 equals R. We know R is the percent of the decimal, so if I multiply that by 100, I then get the 1.4%, same as we had before. So this so looking back at the percentages, this 101.4%, that is the new amount. The 100% is the original. And when we subtract them, we get the growth percentage. So I think the percentages is the easier way, but I did want to show you, my pen's really crooked there, that the algebra works as well. So if you prefer the algebra, you can always do that, or you can reason it through. We're then asked to rewrite it as a word problem. So in 1900, the world population was 1.6 billion. That's our start. At that time, it was growing by 1.4% each year. And so that's the words that describe the exponential model that we have in this